This problem says find the radius of convergence. Now I know previously I've told you guys to use the ratio test. Now this one wouldn't work. And the reason why is because I have k's in here too. If I just had a k on the outside, yeah, that would be fine. But since I have the k's on the inside, I'm going to have to do k plus 1 for all of those, for even these in here. This gets to be a real headache with these because nothing really cancels. So what we're going to end up doing here is the root test. That's what we're going to use now, the root test. So here's the root test. So now we have to do the limit of the nth root of a sub n and the absolute value of that. So that's what we're going to do now. So I'll leave that there for the time being so you can actually see this worked out a little bit. So this is the limit as n goes to infinity. And this would be the kth root of k minus 1, over 2k plus 3 to the k, and then x. Well, what I'm going to do here is I'm going to take this k away here, and I'm going to do it this way. If this is okay with you guys. Actually, no, let's just, yeah, we're going to do it this way. There. So there's our basic setup to begin with. So now, because we have the kth root of a k, those would cancel. And really, I have the limit as n goes to infinity of k minus 1 over 2k plus 3 times x. And again, the conditions still stay the same here, that if rho is between 0 and 1, including 0, then it converges absolutely. If rho is greater than 1, it diverges. If it equals 1, we know nothing. So this is what we're going to use now for this test. So it's the same as the ratio test, at least the results. Okay, so now this limit, I can say, oh, this is the L'Hopital's rule, because I get infinity on top and infinity on the bottom. So that means I get to take the derivative. And I'm going to pull the x out because the x isn't my variable. So this is really going to be the limit as n goes to infinity. Oh, darn it. Look at this. I got k's and n's. I'm fixing all my n's now, making them k's. Okay, so as my k goes to infinity, I'm going to get 1 over 2. And because there's no k here, then that means that's going to equal 1/2 x. So then we take the absolute value of that, and that has to be less than 1, where our series converges. So what that tells me then, I'm going to have negative 1, and this 1/2 x, and then a positive 1. And right away from here, I would multiply both sides by 2. So then I would get negative 2 to 2. So my interval of convergence, I don't know yet, but I'm not asked that here. I'm only asked for the radius of convergence. So this will be easy. These are actually really nice when I get these. I don't have to test endpoints or anything like that. For this, I can just say now r equals 2. There's the answer. Now again, all this other work is necessary for credit. So make sure you put everything in. But if you look at this, if I think of this on a number line, this goes from negative 2 to 2. Halfway between it is 0, so my radius, in a sense, is going to be 2. That's how the radius of convergence works. Go from the center of the interval all the way out to the edge. So r equals 2. That's our answer.